There we go. All right. So in our first one, we're given that y is a function of t. So we would, I don't know why we would have y equals f of x. I don't know why I said t. It's an x. Y is a function of x. So that's essentially the usual setup, and we don't really need to worry about the table because it's kind of set up in the way that we would normally expect. So we would need to find the slope. So since we're told this is linear, we could just pick 2 points and find the slope between them, but I'm going to do what I usually do and just go a tiny bit step further and just kind of prove that this is linear along the way as well. So we increase by 1 there, but by 3 here, and by 2 here. We go down by 2 here, down by 6 here, and down by 4 here. So our slope would be -2 over 1, or -6 over 3, or -4 over 2, which I'll reduce to -2. Remember, one thing I saw on the quiz every once in a while, make sure you're keeping track of the sign. So you don't want to just say that there's a change in 2. You want to note that it's a change of, going down 2, because then you'll have the wrong sign on your slope. So now we get to pick whichever point makes us happiest. I'm gonna pick, I don't know, I'm gonna pick 3, 3, because I feel like it. Again, as long as everything else has gone correct, you should get the same answer. Actually, no, I'm not going to pick 3, 3 because then it's harder to see like which one goes where. I'll pick 1, 7. I don't like picking ones that have the same value for x and y. So y equals our slope of -2 times 1 plus b. So -2, and we're going to add that over to the 7 to get 9 as our b value. So y equals -2x plus 9. Which, just triple check in my brain that it's working with the rest of them. +4 plus 9 is 13, good. 6 plus 9 is 15, good. Now for the other one, s equals, what am I saying? S is a function of t. So remember, the nice thing about this is you just write it out as you read it. So s is a function of t. So essentially, these s's are acting as our y's and these t's are acting as our x's. So we need to be kind of careful because the table's almost backwards to how we would expect it. So if we figure out what's going on here, we're going down 2, then down 4, then down 2. This is in my way. And then we're going up 4, up 8. Why is my brain not working all of a sudden? And up 2, 4. It said 2, I wrote 4. So our slope here, whoops, what happened? What did I do? There we go. So our slope here, since we need our change in quote-unquote y's over change in quote-unquote x's, this would result in a change in s over change in t. So we'd be looking at -2 over 4 or -4 over 8, which would both reduce to -1/2, -1/2. And so here we get to pick whichever point makes us happiest. I'm going to pick, ooh, this one's gonna be a little gross. Might be. Well, it is what it is. I'm gonna pick 8, 3. So we would have our s value, our slope times t plus b. So this one's gonna have a fraction in it, or a decimal, whichever you prefer. I actually don't know what that is. Right. So we had -1.5 plus b, so we'd get 9.5 as our b value. So s would be -1/2 t plus, I'm going to change 9.5 over to a decimal just because I wrote the other thing as a decimal, but if you mix and match it, it's really okay. But that would be 19 over 2. Questions, concerns on how I got either of those? So If you have a question, feel free to keep typing it out or anything like that. So again, I'm almost going a little too far when I'm doing these slopes. You can always just calculate the slope between 2 points. So you can pick whichever 2 points you want and just find the slope between them. Now, to clarify, you need to be told that it's linear to be able to do that. Like if you're asked to find if it's linear, then you have to do every single situation. But here, since we're told it's linear, we don't really need to check. I just want that kind of extra step to prove that it was linear. So you could just pick 2 points, find the slope between them, and just use that as your slope. You don't have to do this full little loop thing if you don't want to. You can do that if you want as well. Doesn't take too much longer necessarily. And then once you have your slope, plug it into your y equals mx plus b format, solve for b, and then write your answer. I'll wait like 5 more seconds if there are questions or concerns on that. And then I've got a couple things to say before we jump into our notes for the rest of the time. All right. So a couple things I want to say real quick. I'm gonna probably send out a announcement / email about this later, just in case people aren't listening or aren't here or anything like that, and I want to make sure it's actually in it's formally written somewhere. There's some miscommunication about quizzes. And it's partly my fault because I didn't realize how Blackboard handles it. It handles it in a much worse way than I thought. So your quizzes have a time limit stated on them, yes. Okay, I'll come back to that in just a second. So your quizzes have a 20-minute time limit on them. It is unofficial. And so what it's there for is it's to tell me and you whether or not you're quote unquote taking too much time. Okay, so the exams, which you have one coming up in 2 weeks, by the way, the exams are formally timed. So on an exam, you will have 60 minutes. It's a 50-minute class, so I give you an extra 10 minutes. You'll have 60 minutes to complete the exam, and at the end of the 60 minutes, it'll just automatically submit if you're not done. You don't even get the chance to click submit. It submits itself. So with the quizzes, what I'm trying to do with this time limit is to let you know about how much time I'm expecting you to take maximum on these quizzes. These quizzes, I try to make them only about 10 to 15 minutes, 20 minutes max. So you have the 20-minute time limit on something that I think should hopefully only take around 15 minutes. So if it's taking you longer, you just want to take that as I should really study this a bit better, so because I need to be a bit faster for the exam. But anyway, the way Blackboard handles that is not the way I thought they did. So it has this little time thing at the top, and if it really stresses you out, you can just like hit this little arrow in the corner. It'll make it go away. But at the end of the 20 minutes, this scary message pops up. It says time has expired, and it looks super official. Official is not the right word. It really looks like it's just like you've ran out of time. Sorry, not sorry. But if you click cancel, you can keep going, and there's no penalty for that or anything like that. So on a quiz, if you're taking it and it's taken more than 20 minutes, but you want to keep going, you can. You just have to click cancel, and then you can keep going. I do apologize for that. I thought Blackboard just lets you continue without much hoopla. I didn't realize that box popped up and like freaks everybody out and makes people think that time's up and they're gonna get points off if they keep going. So anyway. Oh, and now my laptop's angry. So let me pop back to the warm-up real quick. There was a question on that once my laptop decides to be happy again. There we go. Getting a slope of -2. Okay, are you talking about part B, Brianna? Let me clean this up a little bit. Okay, so yeah, I believe I know why. So there's a tiny trick to this one, and that's because it tells you what type of function it wants you to choose. So if you just take this table and you look at it, if you're assuming that the quote unquote X values are on top and the quote unquote Y values are on the bottom, and you're doing, let me shift over a little bit. So if that phrase wasn't there that I highlighted, if S is a function of t, then you would probably be finding the slope as 4 over -2 or 8 over -4, which would reduce to -2, of course. But specifically because we're told to take S as a function of t. So S as a function of t means that S is a function of t. So that phrasing kind of sets up the format. And what this means is that we need to take the S values as our Y's. They act like our Y values because I feel like most people like thinking in terms of X and Y's instead. And so, yeah, exactly. So it's actually, this table is almost upside down to how we would hope we would be able to read it. So when we're finding the slope, we need to be really careful because a slope here would need to be a change in S over change in t. So it needs to be the 2 over 4 or 4 over 8 with the negatives that I forgot to say, instead of the other way around. So if this was t as a function of S, then it would be a slope of -2. Hooray. So yeah, you need to be careful if they state the kind of quote unquote direction that they want the function to take. If they don't state it, then you essentially get to do whatever you want. But if it says a certain direction, you got to make sure to be careful. All right. Nope. Go away. So we're going to skip that warm-up problem. We'll come to that on Monday. We'll do that as our warm-up on Monday. So we'll start with these new definitions if we're good to go. 1 second. Okay. All right. Just kidding. 1 more second. Okay, yeah. All right. So we're going to now be talking about some economics applications. Now, if you've taken an actual economics course, this is going to be like baby economics. We're not really getting into the nitty-gritty economics, but it's kind of how we're going to be looking at cost, revenue, and function profits a lot in this class. So the cost function, which is usually written as C of Q, gives the total cost to produce some Q amount of items. There is something called the fixed cost. Let me make that smaller. Something called the fixed cost, which is the cost associated with producing no units. So essentially, it's usually, the material cost if you've, renting out an office space or a warehouse space or something like that. Essentially things that you have to pay no matter whether or not you actually make any things. And then there's going to be the marginal cost. This is also sometimes called the variable cost. I usually default to marginal, but if you see variable cost, or I say variable instead of marginal, they're the same thing. So the marginal cost is the cost of producing the next item. So essentially, it's almost like if I was like knitting things or something, and I was knitting mittens, and every set of mittens I make used $5 worth of, wool or whatever. Then the marginal cost for making my mittens would be $5. It costs me an extra $5 in materials to make that next pair of mittens. So if cost is linear, which is what we're going to be focusing on at first, just linear cost functions. If cost is linear, marginal cost is going to be represented by the slope. And fixed costs are going to be represented by the y-intercept. Maybe I should be careful and say vertical intercept. Because actually we usually aren't working with y's here. It's usually in terms of q and p. Now, a large majority of the time, these costs and revenue and profit, which we'll talk about in a second, functions are given as a function of q. So like Q would be acting as your X value, but sometimes we can have it as a function of price. So you do want to be kind of careful to make sure that you're setting up correctly if they're giving you which variable they would like to be a function of the other. So let's say that we have goods are us as a cost formula of 9,876 plus 0.5 Q to produce Q goods. What is their fixed cost and what is their marginal cost, and what might each cost represent physically? And we can just kind of go crazy with those and get a little creative. So our fixed cost and marginal, let me leave myself enough space. So our fixed cost is going to be our y-intercept. Since this is a linear function, it's the thing not attached to the variable. So that's our 9876. And if I wanted to think of a scenario, there's a lot of scenarios that this could be. I could say something like this could be, let me list a couple options. It could be rent for a building. It could be utility bills. It could be labor cost. It could be material cost. Well, I should be careful with this. If this is like a lump sum kind of deal, actually, I'm going to get rid of that there. It's going to cause too much confusion when I write the next thing in the marginal one. So this would be not quite material cost. It's like it depends on the material. If it's like you need, okay, maybe can I think of a better word? That's my brain's starting to work a bit better. Not material. Let me write this. I want a better word than machine, but it's on the tip of my tongue, but I can't think of it. It's like the things you need to actually make the stuff. You know, any machines that you need, any, you know, materials that you would need to actually make the thing. Like if you're knitting things, you would need equipment. Oh my gosh, thank you. Equipment cost is what I was looking for. Capital would also be an option, but equipment is definitely the word I was looking for. Any equipment costs would be considered fixed. You know, essentially something you just need to buy right away to be able to use, and you don't need to necessarily keep buying every single time you need to make more stuff. It's like I would need knitting needles if I wanted to knit a bunch of things, but then for every single pair of mittens I would make, I would need extra yarn. So the yarn would actually be considered marginal. So let me talk about that a bit more. So in this case, our marginal cost is just at 0.5. Let me block that off a little bit. So this could be, really there's one main option here, and this is why I made sure to get a different word than material. This is your material cost. You could potentially, nope, I'm not going to say that. That's going to be too confusing. So again, it's like the difference is if I'm knitting things, then the yarn is something I need for every single pair of mittens. So that gets lumped into a marginal cost because I need that for each additional mitten. But if I'm making mittens and I'm knitting them, I need knitting needles right off the bat, and I don't need a new pair of knitting needles for every muffin for every mitten. So the knitting needles would be considered a fixed cost, and then the yarn would be considered a marginal cost. Hopefully that makes sense. Essentially, anything you need for each additional item is a marginal. Anything you kind of need at the start would be considered a fixed. Anyway. Catch up, chat. Where is it? Yeah, your supplies. That's another good word. Your supplies is exactly. All right, so now we've got our revenue function. So that's the idea behind the cost function. We'll do more about that in a second. So our revenue function, which is usually written as R of Q, is going to give the total revenue received by a firm for selling a quantity Q of some good. So I hate using the word revenue in the definition of revenue function, but it's essentially, you know, how much money do you make from selling that many items? Now, the one thing we're really going to want to remember for revenue, it's going to come back a lot. We're going to need it every once in a while, is that revenue can be thought of as price times quantity. or usually I'll just abbreviate it P times Q. So price times quantity. Every once in a while, we'll have a function that gives us the price. We'll talk about, maybe we won't get to it today, but we'll eventually talk about supply and demand functions. And sometimes if you know the demand function, you can then find the revenue function by remembering that revenue is price times quantity. Which makes perfect sense because the amount of money you make from selling Q amount of things is going to be how many things you sold times how much each sold for. Price times quantity. And can I leave that in there a little bit? Not really. So let me zoom out a little bit so I can at least scroll down and get here. There we go. And then our profit function. Now our profit function is usually written as pi of Q. I honestly don't know exactly why it's pi and not p. I assume it's probably a thing to avoid with probability. P is often used in probability to say the probability of something, so I assume they're just trying to avoid that. If you write P of Q as the profit function, I will know what you mean, and that is perfectly fine. But officially, it's usually written as pi of Q. And here, pi is just representing the function name. It's not really representing the number pi in a way. So profit is going to be calculated by revenue minus cost, which again makes a lot of sense if you think about it. So profit is essentially the amount of money that you get to take home at the end of the day and actually, have. So if the revenue is the total amount of money you made, but then you still have to pay people what you need to pay them or else they'll get angry at you. So the amount of money you actually get to keep starts with the amount that you made minus the amount that you have to pay people. And then what's left over is what you are left with. I say that because a lot of people will end up doing this backwards. They'll accidentally calculate cost minus revenue. So I think having that kind of extra way to think about it logically, realizing that if you start with all of the money that you made that day, but then you still have to pay the people that you need to pay, that might help you remember the direction that it goes. So of course, we could just write this in symbols as well as R of Q minus C of Q. Yes, the order is very important. So the order on the profit function is highly important, or else you're going to get essentially the correct numbers, but the wrong signs. So the negatives will be in the wrong spot, and that's not good. So it needs to be revenue minus cost. The break-even point for a company is where profit is 0. Yeah. Oh, you mean up this way, maybe? Or do you mean the other way? This way? Okay, yeah. I'll leave that up for a couple of seconds. Good. Creeping back downwards. Okay. No, you're fine. So break-even point is where the profit is 0. I should have left some space below that. So kind of going up here. If profit is 0, I want to make a quick note. So if profit is 0, well, if profit is revenue minus cost, and I'm going to drop the of Q's for a second because they just get tedious. If you add the cost function over to the other side, this is also when revenue equals cost. So there's kind of two ways we could think of it. We can think of the break-even point as where profit is 0, or where revenue equals cost. And that's just like, now you have two options. If you don't actually have the profit function, maybe you just want to set the two equations equal to each other and instead of taking the extra step of finding the profit function, they will get you the same exact answer, but just two different ways to go about it. All right. Let's actually get some practice in then. I'll wait like 5 more seconds for people to write that down. So say Ted wants to start a lawn care business. It will cost $12,000 to buy all of the lawn equipment that he will need, and an average of $4 per job in gas and maintenance. So that's like, remember the difference, his equipment is lawnmower and all that jazz, but then it still costs him some materials, gas and maintenance per job. He will charge $50 per job. So we want to find the revenue and the cost function, where Q is the number of jobs that Ted has completed. And at this point in time, we're assuming everything is linear. So if we have our cost function first, well, that's made up of our fixed costs and our marginal costs. So our fixed cost here is that 12,000 for the equipment. So we'll have 12,000 plus our marginal cost of $4, and that's per job. So that'll be 4Q. Now, of course, you could write 4Q plus 12,000. It doesn't matter the order of those, but whichever floats your boat. Fixed plus marginal, and the marginal gets multiplied by the variable. And our revenue, well, our revenue is price times quantity. So the price that he's charging per job is $50. So our revenue would be 50Q. And that's it. Revenue is like the simplest one in my mind. So what is Tim's marginal revenue and marginal cost? Now I know, oh my gosh, my English is breaking. I know I only officially defined marginal cost. You can have marginal revenue and marginal profit as well. So if we think about the fact that marginal cost is the slope of cost, marginal revenue is just going to be the slope of the revenue function. So our marginal cost is our slope of our cost function. That was $4. And our marginal revenue will be $50, the slope of the revenue function. Essentially how much he's making per job. No, I should be careful with my wording. How much he's charging per job. So say now we want to find a formula for the profit function. So we've got our profit function is our revenue function minus our cost function. You don't always have to write out the symbols for that. I just want to really clarify since we're just starting out here. So we need 50Q. Now, whenever you're doing these, put the cost function in parentheses. Put it in parentheses. Put the cost function in parentheses. Put it in parentheses. Okay, now that I've said it enough times, the reason you have to put it in parentheses is because we need to distribute that negative. And if you don't put the parentheses, you might forget that there's a negative to distribute. So we technically have 50Q minus 4Q, which will be 46Q, minus 12,000. So this came from 50Q minus 4Q. So if I didn't have those parentheses there, you might have had 54Q, which would have been real bad. If there are questions as I'm going along, stop me. Usually I don't ask for questions until the end of the question, but. So C of Q is the total cost for making Q amount of units. Like how do you differentiate and figure out which one to use? It depends on what you're asked. If you're asked for total cost, or they might not even say the word total. They sometimes just say cost. So if you see total cost or just cost, this is going to be referring to C of Q. They will have to say marginal cost if they want the marginal. And that would be your, well, there's another way to write that later, but marginal cost would be the marginal cost. And it just depends on what they're asking. The large majority of the time at this point in time, we're going to be dealing with the regular cost. Yes. So also if you just see just regular old C. Yes. Only if they mention marginal will you actually use the marginal. They will have to state the word marginal if that's what they want to look at. I will say At this point in time, we're going to be mainly concerned with total cost. Every once in a while, I'll ask what the marginal cost is. In a later chapter, once we find another relationship for marginal cost, we'll be looking at marginal cost a bit more. But again, yes, if they want marginal, they have to say marginal. So that's like the way to tell which one they want, is if it doesn't say marginal, then it's talking about the regular one. So what is Tim's marginal profit? Well, again, so if at this point in time, we're talking about linear functions. So if the marginal whatever is the slope of that function, then we want the slope of the profit function, which would be, so let me just say marginal profit. So the slope of the profit function is 46. So essentially what that means is that he's actually making, being able to take home $46 for each lawn job that he does, because it only costs him $4 in gas and such, and he charges $50, so he gets to take home 46. What is Ted's break-even quantity? Ooh, I forgot to mention that. Let me scroll back up real quick. Notice the difference in phrasing here. In the definition, it says break-even point. And in that question down there, it says break-even quantity. That is because the break-even point is made up of a price, excuse me, whoops, and a quantity. So there's like the quantity that is associated with making profit 0, and then there's the price that is associated with making the profit 0. So the break-even point is made up of both of those things. If you just want one of them, they will specifically ask for break-even quantity or break-even price. So when they ask for a break-even point, make sure you actually state both. So I'll wait 5 seconds in case people are writing that down. Okay. So if we want the break-even quantity here, it's still where profit is 0. So we can do one of two things. We can either set profit equal to 0, or we can set revenue equal to cost. Since we have our profit function already, we already found it. I usually do that way if we have the profit function. But again, you will get the same exact answer either way. So I'm going to go ahead and set the profit function equal to 0. So we would add that 12,000 over the other side. Divide both sides by 46. You'll get 260.87 if you plop that in a calculator. Now, on an exam or quiz, if I do not specify, you do not need to round. If you did, I would accept it. But sometimes I will say, you know, round to the nearest whatever, because that makes more sense. Like he can't do 0.87 of a lawn. Well, I guess you can stop like more than 3/4 of the way through, but someone would probably not appreciate that. So we're going to go ahead and say that this would be about, let's say about 261 lawns. Again, if on a quiz or exam, if I did not specify that I wanted you to round, I would accept 260.87. But usually I do want you to take that kind of extra logical step and realize that doing a fraction of a lawn is probably not good business. So about 261 lawns. Let me take a step further. I know we weren't asked this, but what is the break-even price? So we weren't asked that initially, but let's go ahead and go a step further and find that. So to find the break-even price, you can do one of two things. So you're going to plug the quantity into revenue or cost. Notice I do not say profit. So if you plug the quantity into profit, you're going to get 0, because that's the point of the break-even point, is that it's got a profit of 0. What we mean by the break-even price is essentially how much cost does he have to put into it? How much revenue does he have to make out before it will break even? So we actually want to know that price point. So I like to usually plug it into revenue because revenue is usually a nicer function. So we'll take that, we'll take the decimal point to be a bit more exact here. So if we plug that 260.87 into our revenue function, which was 50Q, so 50 times 260.87, will give us an approximate cost of $13,043.50. So to officially break even, he has to put in that much money. It'll probably be a tiny bit more because he has to finish that other lot. But officially, the break-even price would be that $13,043.5. And that would, of course, be in dollars. Questions, concerns on that question at all? Okay. I'll try to leave some of this in there, but I want you to try problem 3. I will give you a minute and a half to try that. So essentially it sets it up for you. You start an online business selling paintings. Shelly has $12 fee for each domain, for her domain. So essentially to get the website, she has to pay $12. Each piece that she makes will be sold for $75, and her supplies for each piece, for the piece, but it should probably say for each piece, will cost $35. Write formulas for the cost, revenue, and profit. So I'll give you a minute and a half now that I've stopped babbling to try that, and then we'll go over it. All right, so we've got our cost, revenue, and profit that we need to figure out here. So our cost is made up our fixed and our variable. So the fixed here is just going to be that $12 because the $12 fee, she just needs to set up the website. And once she pays that, it's done. She doesn't need multiple websites or anything like that. It's just she's got to pay $12 to get the domain and then she's good to go. The marginal cost will be that 35 because that's the cost per piece. Like that's the paint and canvas maybe that she needs. So her supplies for the piece, since it's for that particular piece and not just a generic supply like a easel or something like that, it's a supply per piece. That would be a marginal cost. So we would have 35Q plus 12 there for our cost function. Revenue would be how much he's selling it for, which is 75, so 75Q. And then profit is our revenue minus our cost. Always put your cost in parentheses. So 75 minus 35, 40, and minus 12. Questions, concerns on that? All right, I'll wait a couple more seconds. I believe, yeah, we're moving on to a slightly different concept. Might not get too far because we're almost done, but all right, let's go. So the supply curve for a given item relates the quantity Q of the item that manufacturers are willing to make per unit time to the price for which an item will be sold. And the demand curve for a given item relates the quantity Q of the item that is demanded by consumers per unit time for which the item will be sold. And I'll try to say that in a bit more modern English in a second. And then we have something called the equilibrium point, and the equilibrium point is where supply and demand are equal. It's almost a very similar idea to break-even point, but it's just now in terms of the supply and demand instead of like cost and revenue being equal. So if this phrasing doesn't make much sense, essentially this is what's going on. So the supply curve, essentially say I want to start making my mittens. I'm just going to go back to the mittens. So say I want to do a business making mittens, and I go to, the person who's going to give me all of the, the wool that I need to knit my mittens. And I'm going to say, hey, I would really like to strike up a deal with you, and you're going to supply my wool, and I'm going to make mittens. And they're like, all right, cool. How much are you going to sell the mittens for? And I'm like, I'm going to sell the mittens for $50. And they're like, whoa, that's a lot of money for mittens. We're not going to give you much wool. We're only going to give you enough wool for maybe 100 mittens or something like that. And then I said, okay, well, just kidding. I'll sell my mittens for only $25. And they're like, oh, okay, that's much better. We'll now give you enough wool to make 500 mittens. It's essentially relating how much the manufacturer is willing to make me, depending on how much I'm going to sell the things for. Whereas the demand curve is essentially I go out to the public and I'm like, hey guys, I'm going to start making mittens. And like, they're going to be $50. And people are like, we're not going to buy your mittens then. And I find that only like 5 people are going to buy my mittens if they're $50. Whereas if I go, okay, hey guys, just kidding. The mittens will be $25. And they're like, woohoo, $25 mittens. And then I find out that 100 people will buy my mittens. So the demand curve relates essentially how much of that product I will be able to sell, how much is demanded by the consumers for how much I'm going to sell them for. So that's kind of the idea behind it too. We have time to do one of these at least. So let's start off with a question here. So let's say that the supply curve for a given product is Q equals 600p. This is a different question than I thought it was. There we are. And the demand curve is given by Q equals 33,000 minus 500p, and we're just going between 0 for our price and 60. We're just going to cut it off. We don't always cut it off like that, but in this problem we're going to. So at a price of $10, what quantity are consumers willing to buy and what quantities are producers willing to supply? Will the market push the price up or down? So consumers willing to buy. So that's going to be our demand. And so our demand, our quantity is in terms of price. So we're going to be plugging the price into the function. I missed a 3 there. And it's for $10. This results in 28,000. So if I sell these, whatever they are, we're not actually told. If we sell whatever these things are for $10, there will be 28,000 of them demanded. Producers willing to make. So that's going to be our supply. It's going to be 600 times 10, which will be 6,000. So I'm going to have 28,000 of them demanded, but I'm only going to be able to make 6,000 of them. That's not good. I'm going to have a bunch of people that really, really want whatever this product is, and I will not be able to make them because my producer's like, no, I'm not doing it. So what that would actually tell us is that we probably need to actually up the price. Because if you notice the way these functions are working, the larger the price, the more I will be able to make. And the higher the price, the less that's going to be demanded because we're subtracting that out. So what this would actually tell us is we would actually want to up the price. Is that a profit? That's a hard question to answer because in terms of the information that I have here, I can't say whether or not there's a profit. Also, we're out of time, so if you need to run somewhere, run. I'll try to finish this question up in like a minute or two. So all this is telling us is how many are going to possibly be sold and how many can I make. I don't have any information about how much profit I would make off of this. This isn't saying that like, oh, because a bunch of them would be demanded, but I don't have them, that I make a bunch of profit. It's actually a terrible situation because a bunch of people want them and I actually don't have that many products to give them. So this is just saying that I would love to be able to sell the 28,000 of them, but I only have 6,000 of them to give. Yeah, that's fine. If you have class, bye. So all this tells us is that we would actually want to increase the price because the point is that we actually want these two numbers. We actually want these two numbers to actually be as close together as possible. And when they're close as possible, that's actually when we're probably going to make the most money because we actually have the amount to sell that we actually make. So like we wouldn't have extra items left over. We wouldn't have people who want things but don't get them. So we actually want these numbers to level out. So we'll come back to this again on Monday. Again, we're out of time. And I'll talk about that again on Monday to try to kind of hit that home. But we don't know about profit by just looking at cost and revenue. We want, yes, exactly. That's why it's actually called the equilibrium point, is because we want them to be equalized. We want to bring equilibrium to supply and demand. All right, if you have questions, feel free to stick around. Otherwise, feel free to leave. And I will see you on Monday. Have a great weekend. Again, stick around if you want to talk a bit more. Otherwise, see you later. But yeah, see ya. That's pretty much, you're exactly right, is we want to maintain an equilibrium here. Yeah, I can go back up.
Excuse me, ma'am.
Yes?
Ma'am, could you also give the answers for the quizzes we take?
Yeah, so I gotta triple check that I have the correct options up. There should be a way for you to check the answers via the grading center because there's also not everyone receives 100% the same quiz. There's like numbers changed and everything like that. So let me triple check how to go about doing that. I think if you go to the grade center, you should be able to like click on the grade and it should open up the answer key, hopefully. But I will send out an email later about exactly how to go about doing that.
Cause ma'am, I just checked my quiz 3, and like I got 21 out of 24, and then like you told me that where I made the mistake as well, but we can't see the answer. If you
Okay,
understand.
let me. Oh yeah, I don't have the right options up. So let me change those options and hopefully then it will.
I'm guessing the questions on the quiz are like the questions which are going to be in the exam as well, right? Something like that.
Yeah. I also so next week I will be putting out a review guide with some questions as well. And the review guide is what I highly suggest going over because that will be very similar to exam questions. The second thing I suggest is also looking over the quiz questions. So yes, the quiz questions are similar to the type of questions you might see on an exam.
Oh, okay, ma'am. Thank you.
And I think I've changed the settings now. It might take a few minutes to register, but if you still can't see the answers in like a couple minutes, shoot me an email and then I've got to figure out why Blackboard isn't doing what I want.
Yes, ma'am. I'll check it and I'll email it to you. Thank
Great.
you. Nice day. Bye.